Welcome to our talk about leading Superyacht Design with a collaborative platform enabling computer-aided design with integrated scalable visualization and virtual reality. This talk is presented by Hazen Yachts and Dassault Systems CATIA. I'm very proud to introduce my co-speaker Alexander here.
Hello, I'm Alexander Breuning. I'm the Application Manager for Computer-Aided Design at Hazen Yachts. My role at Hazen Yachts is to develop the application of computer-aided design in the company. This is for design and engineering processes, but also to support the production people with 3D data.
My name is Stefan Ritz. I'm the Portfolio Management Director for the Product Experience Portfolio at Dassault Systems CATIA. This portfolio is including solutions for integrated high-quality visualization, visual simulation, virtual and mixed reality, as well as visual decision-making tools. Before we start the presentation on our collaboration and unique technologies, let's take a quick look on both companies involved in this project, Hazen Yachts and Dassault Systems with its brand CATIA.
Hazen Yachts was founded in 1978 by Mr. Franz Hazen. Mr. Hazen developed the company with drive and solid principles into the renowned superyacht maker it is today. Hazen Yachts is known for its innovative full aluminum and steel-hulled yachts built with meticulous attention to detail. Hazen Yachts is located in Os, a location in the fascinating Maas and Rhine Rivers Delta here in the Netherlands. Here we have all the facilities, know-how and quality craftsmanship to build the dreams of our customers. Hazen Yachts sports leading-edge new technologies, such as the fast displacement hull form, which features resistance values some 20% lower than well-designed hard-shined hull forms. Hazen Yachts already built several yachts from 50 to 80 meters length using the FDHF hull concept. Hazen Yachts are available with hybrid drive propulsion systems, allowing them to sail on electric power where suitable, and efficient cruise where necessary without compromise. The presentation here is centered around Hazen's 50-meter semi-displacement platform, which demonstrates the 3D design and engineering and virtual review technologies we use and develop. This yacht platform marked also the introduction of the Dassault Systems 3D Experience platform, which is now replacing our use of CATIA V5.
Dassault Systems might be known to many of you for our 3D design software, for instance CATIA. But we are more. We are the world's leading software provider for applications to transform the way products are designed, produced, supported, and experienced by humans. And our 3D Experience platform solution is used to imagine, design, experience, and build products together. And this from the smallest everyday object up to whole buildings and even entire yachts. We are the 3D Experience company, and we are a purpose-driven company. That means we enable transformation by leveraging science and technology with a target to harmonize the product with nature and life for a better sustainability. This vision for innovation is shared by our more than 20,000 passionate people from over 130 countries across the globe. But it's not just shared by our team members, it's also shared by our more than 12,000 partners and more than 290,000 customers worldwide. And it's also enabled by a long-term thinking and investment of the majority of our stakeholders. Transformation is part of our legacy and DNA. We have been one of the catalysts and enabler of some of the world's greatest digital industrial transformations. Starting with 3D design, then introducing 3D digital mock-up to represent entire systems and complex products, up to managing them over their life cycle with 3D PLM. With the 3D Experience platform, we now take also in consideration the impact of usage and perception, which we will see later in this presentation. And finally, these experiences are brought to humans, which represent life and our latest stage of virtual human experiences. With our 3D Experience platform, we provide experiences for different disciplines with the power of our 12 brands to support the need of specific users and collaborators. We serve 11 different industries with tailored industry solutions to address their specific challenges. This presentation is focusing on solutions for the challenges of yacht design in the marine and offshore industry, supported by design applications of the brand CATIA. After we know now our companies a little bit better, let's start our presentation with an initial question. Why do we need a collaborative platform for superyacht design? In order to answer this, we have to take a look on typical disciplines that are involved in design, engineering, or manufacturing of a superyacht. Like for instance, semi-displacement hull design, structure design, space coordination design, or systems design. Or on the other side, styling, manufacturing and production planning, and interior design. And last but not least, not being part of a design or engineering discipline, but very impactful for the process, the customer. And all of these participants share that they want to work together and collaborate with each other. They want to jointly take decisions that are connected and traceable later on. That they need a single source of truth that is accurate at any time and that provides anyone in the process with the right experience so that the design meets the customer's wishes. And that's the target of the 3D Experience platform, to enable collaboration and decisions between all the disciplines continuously from the beginning to the latest process steps that are needed to build a superyacht, to provide 3D experiences that are answering the most relevant questions for every specific discipline, while at the same time enabling everyone to see the yacht design through the eyes of the customer. Hazen Yachts is already using the 3D Experience platform today, for instance in styling as an early discipline that is already working on 3D Experience. Also in structure design that is using it to provide engineering answers to a lot of ideas. Space coordination design with all of the connections that it has to other disciplines. Systems design with its high integration complexity. So let's take a closer look on how Hazen is using the 3D Experience platform together with Alexander.
3D Experience is used in 4 departments: the preliminary design, shipbuilding, mechanical and engineering, interior engineering departments. The modeling topics are foundation models such as hull and structure grid, styling model, space reservation model, structure model, systems routing model, mechanical equipment placement model, and interior integration model. Styling model. The styling model represents the final well-straight shapes of the entire yacht exterior. It brings the vision of the yacht as expressed by its designer into a high-quality surface model. The model ensures that we can peruse the sculptured shapes of the design accurately. The excellent surfacing capabilities in 3D Experience are put to full use here. It is a process that is similar to the automotive and airframe design, which use the same software. Space reservation model is a model shared by all 4 departments, which were the preliminary design, structure, mechanical, and interior engineering departments. It coordinates the use of space by each discipline by showing initial space claims for each department. It supports communication between the departments to find best solutions. It promotes efficient use of available space. It is used throughout the design and engineering lifecycle next to the other models we'll mention. Structure model accurately models the structure from basic scantling calculations to the exact part geometries for production. It uses structure functional design for preliminary modeling, supporting FEM, and parametric optimization of strength, weight, and proper distribution of stiffness. Uses the automated translation of surface-based modeling to final solid-based representations of the parts provided by this software portfolio. The models contribute to the exact virtual yacht digital mockup, supporting the work in mechanical and engineering of the interior. Systems routing model. It is a 3D model of all the approximately 100 systems in the yacht, showing all the piping, ducting, cable trays, including, of course, the penetrations through the bulkheads and the decks. Coordinates the location of these systems with the space reservations, with the structure, among each other, and with the interior. This routing optimizes design for efficient use of space efficient placement of the systems, serviceability, safety, and many more considerations. The use of 3D is vital to support a growing number of systems and their complexity within the available space. It is like a complex puzzle and is a fascinating skill challenge for the engineers. Mechanical equipment placement modeling. It is a beautiful example of the application of complex 3D digital mockup work. It is used to study and define the technical areas of the yacht, such as the engine room, wheelhouse, and underfloor areas. It brings all the components to their correct places and studies relevant aspects such as proper function, safety, serviceability, and assembly sequence. It results in some of the largest submodels we have and therefore requires the capabilities of this high-end CAD platform. With this high-end CAD platform, in this way, we can support next-level applications such as VR review, shown in this presentation. Interior models. The interior models are integrated into the full yacht digital mockup. It helps the other topics, such as systems routing and component placement. This allows full exploration of the geometry in the yacht, including space use optimization, clash detection and resolution of clashes, allowing efficient final assembly, meaning first time right assembly.
After this good overview of today's usage of our platform at Hesen, let's take it a step further and remind us that with the 3Experience platform, we want to be even more inclusive, with experiences that are answering the most relevant questions of all connected disciplines, like manufacturing and production planning, or interior design, while at the same time enabling everyone to see the design through the eyes of the customer. In order to reach this, we improve the communication of our platform users with accessible realism. We extend computer-aided design and simulation tools with high-quality visualization and virtual reality. This way, we create a common language integrated in the design, engineering, and simulation tools, and have the vision of the final product present at any time, and if needed, also accessible for every decision. For this, we had to integrate a scalable visualization directly on the managed CAD data, inside the design, engineering, and simulation tools, starting by integrating a performing CAD visualization, supporting also high-quality real-time rendering on CAD data, and supporting ray tracing and global illumination on CAD data for visual validation. This way, we could support all the use cases from very interactive ones up to physical accurate ones for validation, visual validation use cases. And this is empowered by the Dassault Systems stellar rendering technology. Let's start with a look on our integrated CAD rendering performance and how a yacht design project can benefit from it directly. When you see the data of our yacht in design, it gets quickly very clear how complex it can finally become. The integration of many components, as for instance here the exterior and hull, complex systems, and interior setups, create a combined and rich data set that helps the involved disciplines to collaborate on their dependencies. Here you can see that our integrated CAD rendering performance is enabling efficient cross-team reviews and collaboration on even complex system routing models, mechanical equipment models, or even the whole engine room with interactive 3D experiences. But when you take a close look, you can see that the packaging here is very dense and that the pure screen review might be limited to be understood just by some experts. And even for these experts, the location of some systems, the space reservation, and accessibility might be difficult to judge here on screen. But on the 3Experience platform, we have the capability to start a virtual reality session directly in any 3D application and assess the data from the inside with just 3 clicks. With this capability, you can literally jump into your preliminary engine room data and assess it from the inside at any time. You can explore connections and dependencies standing in front of your digital mockup. See the packaging and all the components in their correct places. Navigate and explore intuitively. Understand maintainability and reachability in one-to-one scale. Do measurements like you are used to from your computer-aided design software. Do hide and show to see through more complex parts of your data. Explode to find specific details in this complex engineering puzzle. And do intuitive sections to cut through the dense areas and reach essential views. We enable these immersive capabilities with the 3D Experience CATIA VR Enabler solutions. These solutions extend all 3D apps on the 3D Experience platform with VR capabilities, make them immediately available in the work environment, with no data conversion and no tool change, directly in the design and engineering tools. For individuals, we offer Immersive Visual Experience and Virtual Reality Reviewer, which provide direct access to VR with minimal barriers and offer all of these tools that you have seen in the small video before, like hide and show, section measurements, and navigation, just as some examples. We also support multiple environments like head-mounted displays, power walls, and caves. For collaboration, we offer the Immersive Collaboration Experience, which is a multi-user VR collaborative experience. Multiple users can work together locally in the same facility or remotely, even around the world. The rendering performance for this solution is provided by our internal real-time rendering, which is also powered by NVIDIA technology. For instance, we have now for multiple releases VR SLI integrated, where we gain a performance with multi-GPU usage up to 80%. We also work on variable rate shading support for the near future, and we have a plan to support multi-view rendering. Now, where we have seen how the current 3D Experience users at Hesen can use our integrated CAD rendering performance and virtual reality capabilities already today, let's see how we can invite more users to leverage these experiences in their workflows. Let's start with a simple example and bring in some lights inside our engine room. Together with the basic shading, the data now speaks to more users from disciplines that are not CAD experts. Now these users can start exploring and assessing the engine room and not feel being surrounded by CAD data, which in fact they are. They can study relevant aspects such as proper function, safety, assembly sequences, or serviceability. For this we can integrate, for instance, CATIA kinematics to be reviewed in immersive mode, enabling an intuitive serviceability check, here shown on a hedge example. We can represent the maintenance worker with a virtual human and show different variations to be checked in virtual reality. You have just seen that we integrated a virtual human in our design and engineering data, which is representing the Dassault Systèmes strategy to provide human industry experiences. These include the human as our driving force to provide people-centric design experiences that bring value to industry-specific workflows. With our CATIA design solutions, we can integrate virtual humans to provide combined human and design experiences. Here in our yacht engine room, we can use a CATIA virtual human to check and illustrate serviceability concepts on our hedge example. In combination with the CATIA virtual reality solutions, you can empower the user to incarnate with a virtual human in a full interactive experience. You can use it for virtual exploration directly in your CAD data and interactive conceptual tryouts like on the serviceability of our hedge example. Let's now take a look on how we can follow up our integrative approach to include more yacht design disciplines in the future. Let's start with manufacturing and production planning, and how we can connect it to our design and engineering process for early collaboration and decisions based on our 3D digital mockup. For illustration, we picked an interesting use case that is targeting a central process in building a yacht. It is when the superstructure is joining the rest of the below structure and components. To plan this assembly, our 3D mockup can face experts with special knowledge on this complex process, performed on the real parts of the yacht, that might have no specialized CAD tool knowledge, and use 2D plannings because of their availability and accessibility at this point in time. Let's now see a demonstration of a possible computer-aided design and manufacturing collaboration on the 3Experience platform. We can start with a design and engineering expert and the 3D digital mockup that he can assess in his 3D environment here on the platform. He can prepare working together with manufacturing by bringing in a 2D plan. Also add the superstructure. And now he can check and simulate the process of lowering the superstructure and manufacturing the superstructure on top of the rest of the structure and components. Once he's done with this, he can place his digital mockup in a 3D environment of the Hesen facilities. Here he can go on with the conception of the outside processes, including his 3D data. Beside the 3D environment and here the structure, he can include more data, like for instance the plan again, placeholders for possible assembly workers later on, and additional components like for instance penetrations, here marked in red. He can also do things and assessments that you cannot do in reality, like for instance bringing in also systems components to have a joint check of systems, penetrations, planned 3D in a realistic environment. He can now invite the manufacturing experts to have a discussion on their planning, 2D plans, the 3D data, and the envisioned process. The manufacturing expert can now also use our VR capabilities to immerse himself in the 3D digital mockup with a realistic presentation and other components that he can check now. Penetrations, plan. You see also that he can see through some parts of 3D and check if it matches the planning here. He can see if the penetrations are really inside his 2D plan that he will use later on. He can start also lowering the superstructure like he would do in the real assembly process later on. See if everything fits together. All the components here, the 3D, the plan. Take the view of the possible positions from the manufacturing workers to see what they can see and not see, what they can check, if they are able to perform all the important tasks and checks during the assembly process that were envisioned. Check also visibility for security reasons. Can the assembly workers see each other? Perform views and checks that are not possible in reality just for preparation reasons here. To really identify also parts that are not visible. So what we saw here is really a full experience of an assembly process with a realistic data set inside your computer-aided design application, leveraging all the different components that are needed. Workers views, plans, penetrations, systems, everything you need to plan a full assembly later on. This was a very good example on how we can take computer-aided design data, add accessible realism to help manufacturing, assembly and design to connect very early in the process and plan the final assembly together. So we have seen in the previous use cases how we leveraged our performance on CAD to enable different disciplines to collaborate and communicate better. We even have seen the first use of high-quality real-time rendering, which enabled us to even include more disciplines by increasing the realism on the look on our data. The solution we are using for this is the Visual Experience Designer, with its main application CATIA Live Rendering. This application enables us to apply high-end visualization directly on CAD data. You can apply, for instance, different kinds of appearance materials. Here the range of capabilities is including precisely measured materials like the EXF format to validate with physical correctness on the one end, and on the other end we support procedural materials with high quality and flexibility for appearance ideation and conception. For this we will see an example later on. And on top we have a visual experience content collection of ready-to-be-used content and materials to be applied directly on CAD data. The application also enables us to embed our product in the right environment. We can use scanned HDR environments or 3D environments like we have seen with the Hesen facilities in the previous demo. This way we can place our data in the right context and enable contextual lighting and reflections. For individual lights we have the choice between different light types with physical-based parameters and also the option for physical-based models like IES lights. For the perfect view on our product and data, we can use cameras with physical-based settings or intuitive and simple view definitions. Let's take a look now on the next discipline that we can integrate with the capabilities of high-quality real-time visualization as well as other high-quality visualization capabilities later on. And that discipline is interior design. Interior design is a special discipline because it might take place inside the yacht building company as well as outside with an external agency. But in any case, the interior design department has to connect and collaborate with the internal design and engineering departments on the 3D Experience platform very early in the process. And also the interior design department is very close to the customer and its final view and vision on the product. So that's also very important for the integration here. Let's now take a look on the next demonstration and how we can improve communication and decisions for interior design, for instance internal or external one, space coordination design, engineering and interior manufacturing for instance. Here you can see an interior designer could directly access the real original 3D digital mockup. He can take a look from the bridge into the captain's cabin, which is our example here. He can switch on real-time visualization and gets a complete different perspective on the original 3D digital mockup data. With this capability now he can start assessing and exploring the dataset. For instance, here he can check how the first appearance of the materials and the different choices of materials are really looking. He can check space and different views inside the cabin. He can check, of course, not just one room, you can check multiple rooms. As you can see, he will now open also the bathroom door. Thanks to our performing rendering, we can of course assess multiple rooms or the whole yacht. And then you can check the design intent and also different perspectives. Talking about perspective, you can go VR at any point in time with 3 clicks as explained before. And with this capability, you can now jump inside your cabin and actually explore it from the inside. So you can have directly built-in VR reviews of your cabin in your computer-aided design applications with real-time visualization switched on. And not just the visualization, also the function can be checked. So you can highlight here all the triggers that expose an interaction to you. You can also use CATIA kinematics in this kind of review, and you can check now a full functionality. You can make a virtual tryout, a tryout session between the interior design department and the interior manufacturing department, and maybe the customer later on also. So it's a full interactive session also. And you can see all the cross dependencies here live by having the right impression of the space. That's just one example that we want to mention here. And of course, you can do the same here in the bathroom where you have much tighter space. So you can check all the functionalities from the inside of the bath. You can use every trigger that is defined by exposing, for instance, kinematics here. You can also see how much you can move inside the room in 1-to-1 scale. You can be in the shower and leave the shower and check so all the different functionalities and all the roominess and space questions you might have. And please be reminded that we are inside your computer-aided design tool here, so we are working on real CAD data. We have now seen how our integrated rendering performance as well as our integrated real-time visualization can help all participants in the yacht design and engineering process to improve collaboration as well as communication. But now we want to go beyond. We want to enable everyone to make reliable decisions. For this, we introduce the highest quality of rendering inside the 3D Experience platform with ray tracing and global illumination on CAD data. The solution we are using here in our example for it is our CATIA Product Design Presenter with the application Product Perception Experience. This application enables designers, engineers, and connected disciplines to take accurate decisions on different product variants. It is offering an intuitive decision setup with a reduced and accessible interface. Here in our examples, you will see that it's exposing just the necessary variants as thumbnails to the user that are essential for his decision. This way, you can work on a touchscreen instead of a CAD workstation, which is more integrative, as shown here in the lower example. You can take, filter, and capture decisions based on different product variants, materials, lights, or even underlying simulations. And all of this with your integrated CAD data. This enables easy collaboration and integration for everyone in the discussion. These capabilities of efficient decision-making combined with our precise rendering enable improved decisions between the interior designers, interior manufacturing, and the customer on materials, lighting, and perceived quality, as we will see in our following demonstrations. So now let's take a look on the designer's desk and see all of this in action. So you can see the designer can evaluate the captain's cabin with global illumination switched on, switching, for instance, here very intuitively the colors of the wall. He can make decisions on materials for the shelf and the doors with different material variants. They are exposed very intuitively here on the left side to him. He can take any position, also see a realistic lighting setup. And so finally find the right packages that he wants to propose to the other teams, and also gives him all the capabilities for a reliable discussion with the customer later on. For decisions on materials, we have integrated different material capabilities in the 3D Experience CATIA design solutions. For the creative part, creativity, for ideation and concepting of materials, we have procedural materials like the substances. For physical accuracy and validation, we can measure materials with the AXF format. And we have more material types, but all of them are brought to the 3D Experience platform in one material model, which is a DSPBR material model. Let's now take a look on one of the material types and how we can use it, the procedural substance materials. What you see in here is a procedural material applied on the bathroom door of the captain's cabin. This material is a formula, no scan, no texture or something. It's a formula that is exposing its parameters on the left side in the menu. This way you can interactively change the parameters and see live the results in front of you in your computer-aided design application on your CAD data. This way, a discussion between a designer, a customer, a designer, and the interior manufacturing department can be facilitated very, very easily and very effectively. You will see that we can also bring images inside the formula. This way, you can have an interactive design review with all needed participants live in your 3D digital mockup. It helps you to design first time right, to save a lot of steps in terms of time, but also investing in prototypes, or being more sustainable in saving real samples that you can discuss then later on. So design is not just about materials, it's also about light. With our solution, we enable everyone in the process to bring in realistic physical-based lighting, be it for the interior as seen here, or for the exterior as seen later on, but also validating the impact of the light of the ambience and environment on the product. We can use these capabilities for another evaluation in our captain's cabin bathroom. So we can see here, there's a normal evening situation with no light switched on, but we can switch on the light. Not just in the bathroom, also in the shower. And then also just in the shower. Switch on indirect lighting while it's going to be night at the outside. Just taking a look on the indirect lighting and let it be morning again. So it shows a very powerful but simple example on lighting evaluation inside your computer-aided design software on your 3D digital mockup. Going to the outside, we can show an example on the interplay between the interior light and the environment light, here on our preliminary design data. We can switch on global illumination for correct reflections and lighting evaluation, and then assess how the exterior light is interplaying when we switch on the interior light. But we have not just one daytime, we have multiple times to assess. So let's make a little bit later a day and do the same again. So this way we can evaluate the impact on the silhouette of the yacht very early when we switch on interior lighting. Of course, all of these computations need a lot of power. That's why we have inside the CATIA portfolio a special solution for CATIA Live Rendering. It accelerates the highest realism in rendering by scaling the graphics resources on a cluster of computers or a supercomputer. It accelerates ray tracing and GI rendering, and that in interactive mode as well as batch rendering. This solution will also officially support GPU clusters with one of the next releases. All of this technology comes together in a perceived quality evaluation. This is a composition that represents a visual simulation on lights, materials, surfaces, space, and many more components. Because at the end, the customer is not interested in one evaluation. He wants to evaluate the product or the yacht as it will be when it's delivered. So let's start our final example of a future use case on perceived quality at the beginning. You remember our designer was able to evaluate the CAD data with real integrated performance. He could switch on real visualization with real-time graphics. And now he is able to leverage with distributed rendering, with measured materials or procedural materials, with lighting and so on, global illumination. This way he can perform a real perceived quality evaluation study. For instance, here our view inside the captain's cabin. You can change different lighting situations from the outside, assessing it in the morning as well as in the evening. Changing now the interior materials. Doing the same lighting evaluation as done before, very repeatable because we have all the realism built into the 3Experience platform. And then switching now not just the material of the shelves and the doors, also on the walls, and changing the lighting situation again. This is finalizing our presentation on the 3Experience platform and how our CATIA solutions on the platform can support leading superyacht design with improved communication by accessible realism, so integration of visualization and virtual reality for all of the disciplines involved in superyacht design. But if you watched carefully, you might have noticed that there was one discipline of our examples that we don't touch in our presentation. The reason is that we focused this presentation on collaboration and decisions enabled and improved by virtual reality and high-end visualization. We are working on other methodologies to integrate these disciplines in the future and support them with the 3Experience platform, like the Naval Architect as an integrated modeling and simulation solution. We are looking forward as Dassault Systèmes CATIA to support Hesen with their future innovative projects, as well as on their vision, together and with our 3Experience platform. We are also looking forward on future use cases or future projects that we can support with our CATIA integrated product experience technology. Finally, I would like to thank Alexander as my co-presenter, the CATIA design team that made all of the demonstrations here happen, and the connected R&D team for all of their work on the applications we were showing.
Thank you for joining this presentation. We hope you enjoyed looking at the beautiful world of superyacht making and all the technology we use to make it all work.